Ignition sequence starts.
Good morning, and welcome to this view of the International Space Station Flight Control Room, where the Orbit 2 Flight Control Team is on duty, monitoring systems in orbit and working with the new expanded version of the Expedition 63 crew. Commander Chris Cassidy and the two cosmonauts he has shared the station with since mid-April swung open the hatch this week to greet three new crewmates who will take over as Expedition 64 when Cassidy and his crewmates leave for home next week.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire. This week, the crew aboard the station doubled with the launch of a new Soyuz spacecraft.
And liftoff.
On October 14th, NASA astronaut Kate Rubins and Roscosmos cosmonauts Sergei Ryzhikov and Sergei Kudzverchkov launched to the International Space Station from the Baikonur Cosmodrome in Kazakhstan. Their Soyuz spacecraft lifted off at 1:45 a.m. Eastern Time, sending the astronauts on a two-orbit, 3-hour journey to the orbiting laboratory, where they'll live and work for the next 6 months.
So Kate and Sergei just docked, and we are really close to opening the hatches.
Upon arrival, they were welcomed by NASA astronaut and station commander Chris Cassidy and Roscosmos cosmonauts Anatoly Ivanishin and Ivan Wagner. On October 21st, Cassidy, Ivanishin, and Wagner are scheduled to return to Earth after 196 days in space, landing south of Zhezkazgan, Kazakhstan. Find out when to watch by visiting nasa.gov/live. NASA's SpaceX Crew 1 mission is coming soon to a space station near you. The first long-duration commercial spaceflight to the space station is now targeted for November, providing additional time for SpaceX to complete hardware testing and data reviews while evaluating Falcon 9 first-stage engine gas generators. During a recent non-NASA launch attempt, the generators exhibited off-nominal behavior. Through the Commercial Crew and Launch Services Program's partnership with SpaceX, NASA has full insight into the company's launch and testing data. If you'd like to hear more about Crew 1 from the 4 astronauts themselves, check out the latest episode of Houston, We Have a Podcast, available at nasa.gov/podcast. Twitter user Chris knows that astronauts enjoy spicy foods in space, but he wanted to know if they also value freshness. In space, astronauts can't make a quick trip to the grocery store and rely on their food arriving on resupply spacecraft. Because of this, much of the astronauts' food is thermostabilized to preserve it for later consumption, but sometimes they receive fresh fruits, vegetables, and even meats and cheeses. Additionally, as part of the veggie experiment, astronauts have begun growing plants like lettuce on board, helping us prepare for long-duration missions to the Moon and Mars. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Part of the agenda during this handover period from one International Space Station crew to another is to brief the newbies on where things are and how they work. The new crew members, of course, fully trained before leaving Earth, but still it's good to get an update on how things really work in space, including, for example, a lesson about how the station's toilet works. Here's a quick look at the answer to that question.
By far the most common question we get asked as astronauts is, how do you go to the bathroom in space? So let's take a peek at the process. This compartment is called the WHC, a NASA acronym for Waste and Hygiene Compartment, I think. We just know it as WHC. It's inside this we call the stall, which is a couple of walls and a door that give you some privacy, because you're right in the middle of node 3 with a treadmill on one side of the toilet, the weight machine we call ARED on the other side, and down in the floor our awesome window called the cupola. And this is a high traffic area, people are coming and going, so you need the privacy. First of all, The desire to go, the need to go is very similar as on Earth, where you just know you have to go. It doesn't feel any different because the fluid might be floating in your bladder or something. No, that's it. It's just the exact same sensation. You know you got to go. Either one, number one or number two. So you've decided that. You float into the WHC. And we have the toilet, which consists of a seat and a metal bucket that we call a keteo, which is a Russian acronym for something, container of something. And but it holds about, depending on how many people are here, it holds about maybe 30 deposits. And we'll talk about that in a second. The urine goes into this hose right here, and this valve is what activates the whole system. Okay, these are the two primary control panels for the WHC. When the system is ready for use, it's a V. This means it's going to the UPA. So we say, check that it's V to P. All right, now we're on the inside of the hygiene compartment. Close the door so that you have your privacy. You take the funnel. This knob right here activates the whole system. It's very, very convenient because it's just one valve operates it all. But in the event that you forget how the system operates, or you're brand new here and you just want to double check, in good NASA fashion, we have a checklist. This is called procedure 2.301, the WHC nominal operations cue card. It's got several blocks for operations. So there's two different ways where the P can go. It can just go into a bucket, which is called a YEDAV, and essentially you're just peeing until that bucket's filled up, and then you have to swap out the bucket. Or you can configure WHC to UPA and the urine processor assembly, and that way the urine is going directly into the system, and that's where we normally keep it. And it's most convenient for the crew members because you're not constantly changing out a tank. So there's a couple blocks to tell you how to make those changes, and some detailed steps if you need to know how exactly to do it. And in case things go wrong with the hardware, not yourself, there's a WHC malfunctions cue card, and we thought of all the different light combinations and the failure modes, but the bottom line is, if there's a red light, we talk to the ground, and together we figure out the path forward. Okay, back to normal operations. Time to go. You take the valve, and you turn it on. You hear the fan noise. Check for airflow. I'll show you that there is in fact airflow. So a little bit of airflow, and that helps everything flow in the right direction. We've got our simulator, and that's where your business goes. You're complete. You want to be a good crew member, so you make sure that you wipe off the excess. Use a disinfectant wipe occasionally or often, and then you simply turn the valve off. But I want to show you number 2 as well, so I'll leave it running and we'll roll right into that. Okay, when it is time to go, you flip this lever here, and that lifts up the lid. The seat here is about 5 or 6 inches in diameter, and there's a plastic liner in there where your deposit goes. What I have here is green beans and mushrooms, and I do not like mushrooms, so I don't mind contributing this piece of food in the name of education. So pretend I ate this yesterday, and now it goes into there. You clean yourself, and the wipes go into there as well. You take this red tab, you pull it off the rim, and depends on how full the container is. This one's about halfway through. We do have a stick, and you push it down in there with all its other friends, and then it's time to put a new bag on. To put a new bag on, you pull that, it's like a hair scrunchie, and get it all so it has max capacity there, and ready to go. Close it up. Close the lid. Now you've gone number one. Number two, you cleaned yourself up, and it's time to turn the system off. You just take this valve, rotate it to off, the fan spins down, the system checks itself, all the lights go out, and you're done. So congratulations, you've just used the WHC for the first time, and you've learned about the process. Hope it's educational, but I don't think it's going to lessen the amount of times I have to answer that question. Thanks for watching.
Everyone in my generation wasn't alive the first time we went to the moon, and we want to do it again, and we want to do it better. The spacesuit in general is like a little mini spacecraft. It has almost every system represented because ultimately it's a life support system. This is going to keep someone alive in a very dangerous, critical environment. We love what we do. We really want to see the system fly and be useful and help a person explore the moon in a more capable manner than they were able to do during Apollo. So it's a great job.
Part of the science mission of the International Space Station is to take advantage of the weightless environment of low Earth orbit to do research on technology that can help future exploration, or life on Earth, or maybe both. For example, the station is home to a 3D printer that can 3D print things and then recycle them and 3D print new things with the same plastic.
The In-Space Refabricator. Presented by Science at NASA. While 3D printers are technology that many people are familiar with, there's one 250 miles above us on the International Space Station, or ISS, that's unlike anything currently found on Earth. It's known as the Refabricator, a hybrid 3D printer that can recycle its hard polymer plastic numerous times to make new items. About the size of a dorm room refrigerator, the device is controlled by operators on Earth who oversee its manufacturing via video cameras. Nikki Werkheiser, NASA's In-Space Manufacturing Manager at Marshall Space Flight Center in Huntsville, Alabama, says, "Recyclers on Earth grind plastic pellets to create their products. But that grinding creates material shear, which prevents you from reusing that plastic again. It's no longer strong enough." For this technology demonstration, the company, Tethers Unlimited, developed a novel recycling process that doesn't require grinding, and that allows us to recycle the plastic multiple times. The ability to reuse the plastic over and over again is essential for long-term space exploration. Werkheiser says, "We can replace a lot of the things we need when we're orbiting above Earth. We just have them delivered on a resupply mission. But when you're in deep space, you don't have that option. You have to have the ability to make all the parts you might need, and without having a large stockpile of extra materials." The Refabricator can even recycle plastic items not normally associated with Earthbound 3D printers. For instance, almost all of the materials that are delivered to the station are packed using foam or plastic bags. Both can be loaded into the Refabricator to deliver items such as a plastic syringe, an eating utensil, or a custom-made wrench. That ability limits the amount of backup materials you need to take with you on a long-range expedition. After all, in space, space is at a premium. The refabricator's technology demonstration will be composed of 2 phases. During each phase, the refabricator will perform 7 cycles of recycling and printing parts while on board the ISS. All of the items printed by the refabricator will eventually be sent back to Earth for testing and analysis to determine the effects of repeated recycling on the material properties of the plastic. Werkheiser notes, "I'm very excited about this technology both in space and back on Earth. I can envision a day where you go to the grocery store and drop your water bottles and plastic bags into a refabricator, and then select your new phone case or a kitchen gadget or the raw filament that you can use in your 3D printer at home." For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more information about how the promise of future exploration is transforming today's technology, visit science.nasa.gov.
From week to week, we show you different examples of science being done on the International Space Station and some of what it takes for the scientists to get their work to the station to take advantage of that environment for their research. In the 20 years that astronauts and cosmonauts have been living and working on this orbiting laboratory, there have been thousands of scientists who have done that work. Now, here's a look back at some of them.
When we are called to do an experiment, sometimes it's a very short lead time. We get a 12-hour call and we're in.
My advisor and I, we have to work together. He's talking to the astronauts, I'm talking to the cadre, and so it's really difficult to take it all in.
Very nice, very good. Try not to break them up, but that's a very good disturbance. And now back and forth the opposite direction.
What's funny is I forget who I'm talking to sometimes. I'll have conversations where it's like, oh yeah, you know, we had an experiment yesterday. It was on the space station. We were talking to the astronaut, Doug, and it's so casual. And it's like, most people are like, what do you do?
Throughout this season of NASA Explorers, you've seen what it takes to send science to space through the eyes of one team of researchers. But they aren't the only ones. For 2 decades, the International Space Station has hosted science from thousands of researchers across the globe.
The importance of the ISS to the research community is huge. From the very basic phenomenon of taking gravity out of the equation is that the ISS is really the only platform we have right now. It gives you access, long-term access, to a microgravity environment.
You can do the experiments, on Earth, but those are almost a precursor to, okay, now let's remove gravity and see what happens. Does it change?
If you're like me, you're a scientist who's trying to unravel the mysteries of science, and someone shows you a shiny new tool, which is microgravity, which can, make science different. And different is what we constantly shoot for.
And different can take time. Before new scientific discoveries could be made, we had to transform an orbital outpost into an orbiting laboratory.
In the early days, it was so focused on building, constructing station and making things safe. And then we started stepping up the number of hours a week that we can use crew time for experiments and research.
That was a very exciting time. The space station would have more capabilities for science. They would have more equipment up there. They would have, freezers, glove boxes, microscopes, etc. Things that we could use to extend the scope of our science.
Space station became a laboratory. It lent itself very well to this concept of fly an experiment, you get the results back, just like you would be in your own laboratory at home. You get more questions as well as answers.
And during that time, a lot was learned. A lot of surprising things were learned. And with that knowledge now, we're developing experiments that are much more advanced in terms of their engineering application.
It's been an extraordinary journey to watch over the past 20 odd years how this has all kind of come together and become, I wouldn't say routine, but accessible. And that's a really powerful thing.
The same thing that gives us new insights also creates unique challenges. Microgravity changes the way everything works, including science.
Working in space, as you can imagine, has a lot of challenges. Everything has to be compact. If you're gonna send something into space, it has to be small. And like, how can you fit like an entire lab bench worth of science into something, you know, your size of your hand? And yet, we still get great information. We still, you know, are discovering things, you know, all the time, and I think it's incredible.
You know, up till the NASA twin study, I was an Earth investigator. The biggest adaptation that I had to make was, well, on Earth, there's an ample supply of all the tissue that you need, whether you need blood or you need urine. So we had to work together and figure out a plan on how to use 1 vial of blood instead of 10 vials of blood. The stress of these precious, this is the most precious samples I've ever worked with, was kind of novel.
There were different students that all got together to create this project. It was really stressing on every review because, of course, you're like, they're gonna say everything's wrong and they're gonna blame it on me or whatever. We knew that it would be difficult, but everybody that jumped into the project pulled through, and at the end, we achieved a successful mission. So I think that's awesome.
What we've learned from more than 3,000 space station experiments is helping us back here on Earth and on our quest farther into space, to the Moon and Mars. These experiments are aiding drug development to fight diseases like Alzheimer's and Parkinson's. We've learned about combating bone and muscle loss, which could assist people suffering from osteoporosis. We've tested how to grow plants in microgravity, a critical component for feeding future space explorers. None of this would have been possible without the astronauts, the humans living and working aboard the International Space Station.
Having the astronauts there to help us was a critical part of being able to do more complicated science, to get higher science yield out of the science that you were doing. They were incredible as people who were there to troubleshoot your experiment should you need anything.
You can never replace a set of human hands. I don't care if it's on station, on the moon, on Mars. There's just something that people can adaptively do that you'll never get a machine to do.
You can collect a lot of data with robotic sensors, but there is still a very big role for humans to play in being able to make on-the-fly decisions.
Yeah, that has a little bit of a bubble on the end. Do you want me to force that out?
If it's possible, if you think you can do it with the tip, yeah, we would appreciate that. At this point forward, this is our DNA to sequence, so the most we can retain, the better.
It was rewarding to be able to put my hands on and know that we're doing productive work. Sometimes we get thrown a curveball and something goes wrong.
Station, Huntsville on 2 for TJ and ABRS.
So now they go, all right, we got to get you to go into the guts of this thing, go find these 2 wires. Have you ever seen those scary movies where the bomb diffuser says, whatever you do, don't cut the red wire? That's kind of what it feels like. You've got somebody who's spent their life developing the research that you're working on, and you're about to go into the guts of his experiment, trusting you very well to do the right thing and not cut the wrong wire. But that's the kind of stuff we need to do when we start going farther and farther away, when we start encountering anomalies we didn't think were likely. And so the crew has to be able to be adaptable to be able to do that. And that was really exciting and fun to be able to accomplish.
TJ, we copy that, and who would have thought a blown fuse would make so many people so happy?
Jeff happened to be orbiting and looked outside the window and saw this eruption just happening. And then he said, hey, I wonder if anybody knows this volcano is erupting. And so he actually called the USGS and said, hey, I see a volcano erupting. Do you guys know about it? First, he had to convince them that he was actually who he was and was actually calling them from the space station. But once you get past that, they then confirmed with other data, like, well, you're right, it is erupting.
So I think those are some of the ways in which the astronauts just play an incredibly valuable role when they're up there helping us with the experiments that we do.
These past 2 decades of microgravity science, they're just the beginning, the start of humanity's continuous presence in space. And the impact of the research in this novel environment is already being felt around the world.
I think most people would not realize how impacted their life is by space. There's a finite number of experiments, but that is a finite number of experiments in a very, very smart community that's very good at sharing the results. There is a real sense of the betterment of humanity in space. You know, it's one place we can all really collaborate and all really get along.
I think it's safe to say that microgravity has allowed writing several new textbooks.
And the more we have more and more scientists working in different arenas to help inform this science, I think the better it will be for the safety and health of the astronauts and the people that follow. We are just at the tip of the iceberg. We have a lot more information that we're going to find out, a lot more information that we're going to need to find out in order to get us prepared for long-term exploration, as we humans are always excited to do.
Space Station now is acting like a test bed, a proving ground for new development, new system hardware, as well as how we're going to be doing research and what kind of research we want to be able to do in a near environment, 240 miles above the surface, versus seriously long distance away where there's time delays up to half an hour-ish that we need to be practicing for, and now's the time to be able to do that.
You know, I would say before I started working at the lab, it was kind of an abstract idea, and there was always the joke about, oh yeah, humans will go to Mars, and it didn't really feel real. And now it feels real, and what's incredible is, I will have a piece of that.
I like to think that some of the work that is being done on the space station lays the foundation for us to be successful on another planetary surface. Will I ever get there? No, it's not likely. But I do hope that someday that somebody thinks back on, wow, it's really great that we learned about X, Y, and Z things from the Paul and Furl research, because we'd never be successful on Mars without it.
We'll learn more and more the farther and farther we go. The first stepping stone, though, is the proving ground that we're calling International Space Station.
If you want to get another look at any of the stories we featured today, you can always find them by heading to YouTube and Facebook. And while you're there, feel free to look around, check out the other cool stuff available about NASA and America's human spaceflight program. And when you're interested in good conversation about human spaceflight, the place to go is Houston We Have a Podcast. It's our weekly show where we talk to folks about their work in all aspects of space exploration. New episodes go up every Friday. Today, Gary Jordan spends some time with all 4 of the astronauts who will be heading to the International Space Station on the Crew 1 mission. Go to nasa.gov/podcasts. You'll find this week's episode there. You will find all of our previous episodes there. You will also find the full library of all the NASA podcasts. They are all also available on Apple Podcasts, Google Podcasts, and SoundCloud.